In this animation, we will examine how to apply Newton's second law of motion to a very general case of motion. We start with a car that is out of gas and two men who would like to move this car somewhere safe so that they can walk to get some gasoline. A free body diagram will help us to set up our solution to this problem. Remember, a free body diagram begins with a labeled coordinate system. The car will be placed at the origin, and to keep things simple for now, we will condense the car down to a black dot. The reason why we can do this will be given later on in the text. To attempt to get the car to move, each man will apply a force to the car. We will assume that each force acts horizontally. One force has a magnitude of 275 newtons and points to the right. The other force has a magnitude of 395 newtons and also points to the right. We will combine all of the forces that oppose these two forces and call the combination the opposing force. This force will take into account things like friction, and we'll assume that it points to the left and has a magnitude of 560 newtons. This opposing force is less than the total force to the right exerted by the two men. There are two forces that act on the car in the vertical direction: the weight of the car by the earth that points downward, and the normal force by the road that points upward. This completes our free body diagram. Because forces are vectors, and Newton's second law of motion requires vector addition, we have to add the vertical and horizontal directions independently. However, because there are two forces acting in opposite directions vertically, and there is no motion vertically, the normal force and the weight of the car will cancel each other out. They will have the same magnitude but point in opposite directions. Because of this, we can remove these forces and concentrate on the horizontal direction. If the forces applied by the men are greater than the opposing force, the car will accelerate to the right. Adding the 275 Newton force to the 395 Newton force and subtracting the 560 Newton force gives us a positive force of 110 newtons. This means that the net horizontal force points to the right, and thus the car will accelerate. Taking this net force and dividing it by the mass of the car would give us the acceleration of the car produced by this net force. This acceleration will continue only as long as the two men can continue to exert a force of 110 newtons more than the opposing force as the car goes faster and faster. When the men stop pushing, the opposing force slows the car to rest as the opposing force decreases to zero.